Okay, all right. So we're going to go through quiz 16 first. Let's consider question 8. Mustafa, can you read for us?
Uh, given the vector with initial point 7, -1, and terminal point -1, -7, find an equivalent vector whose initial point is 0, 0. Write the vector in a component from AB,
Okay,
form AB.
very good. All right, so this is well, a question about the position vector, right? So because position vector is from 0, 0, starting from 0, 0. So equivalent vector is a position vector as follows, right? As we know, it's an initial point, terminal point is a difference, terminal minus initial, right? So -1 minus 7, right? So the first coordinate minus the first coordinate, right? So and then the second is -7 minus -1. Now, -1 minus 7, that is -8. -7 minus -1, that is what? -7 plus 1, right? -7 plus 1, that's -6. So therefore, the equivalent vector is in this form. All right, so -8, -6. 2 points. Okay. Now, some of us made errors on this one. All right, so be careful. It should be what? The terminal point minus the initial point, right? So this is question 8. Question 30. Nick?
Yes. Find the magnitude and direction of the vector 2 and -5. 0 is greater or equal to theta, which is greater than 2 pi.
Oh, oh, okay, good. Yes, very good. Okay, so now for this one, this is a subtle difference between this one and um, the one we discussed in class, right? What we said is if it is in quadrant 4, then you can just use uh, tangent inverse of whatever this one is, right? So in 1 or 4, right? In quadrant 4 or quadrant 1, you can just use tangent inverse tangent something, right? That's what we did in class. Now this one is something, there is a special requirement for theta what? For theta between 0 and 2 pi, right? For 0 and 2 pi. So we got to be careful. Here. So it specifically require an angle that is between 0 and 2 pi. So now for this vector 2 and -5, it is in what? Quadrant 4. Yes, it is in quadrant 4. So the point is in quadrant 4, and tangent. Oh, sorry. This is 5, -5/2. Sorry. -5/2, which is -5/2. Yes, it's -5/2. Okay, the tangent is negative, and it is so the theta, because theta has to be all right. So between 0 and 2 pi, it requires for this question, right? It requires 0 to 2 pi. So we got to find the angle starting from this one and somewhere here, right? The this angle. So what we do is, all right. So it's going to be the inverse tangent, -5/2. So this is going to be some negative values, some like this angle, right? This angle. Now it's going clockwise for inverse tangent -5/2. Then you go what? A full rotation, right? Then you go a full rotation. So that is what? Tangent inverse -5/2, and it got a full rotation. Then you got what? A theta, the coterminal theta, right? Coterminal theta, which is between 0 and 2 pi. Now that's for this one. But if there is no requirement of this theta greater or equal to 0, less than 2 pi, we would just use what? This one will be totally good, right? Will be inverse tangent -5/2, like what we did in class, right? That would be good. But for this one, it specifically requires 0 to 2 pi. So that's why we have to pay attention here. You got a plus 2 pi here. Now the magnitude is easy, right? The magnitude square root by definition, square root of this summation of their squares. So it's square root of 29. Okay. Now for this is 30, right? Question 30 and question 36. Okay. So given, okay, let me just draw this one. All right. So, well, let me firstly, I want to say v hat equals 2 negative 1, right? So 3v is going to be what? 3 times, right? 2 negative 1, which is 6 negative 3. And 1/2 is going to be, this is going to be 1/2 2 negative 1 is going to be 1 negative 1/2. Yes. Okay. So that's going to be these 3 vectors. Now we want to draw these 3 vectors. Okay. Let's just draw. If we want to, we can draw it in XY coordinate. Right. So starting from 0, 0 to negative 1. So 2. Say 2 is here. Negative 1 is somewhere here. Say this one, right? Something like this. This is going to be what? V. This is going to be V. Okay. Okay, this is V. Okay, and then we want to find 3V, 3 vector 3V. So that's 6 negative 3. So 2, 4, 6, right? And 1, 2, 3. So that's going to be somewhere like here. Okay, actually, it's going to be on the same direction, same direction, right? So it's just the length is 3 times. You just extend this long segment till this point, right? To this point. Now this is 3V. Okay, this is going to be like a 3V. Okay, and then we have 1/2, right? So 1 negative 1/2. So 1 is somewhere here, negative 1/2 is. Okay, it's again on the same line. Just shrink the line segment V, right, by 1/2, right, by half. So you got that one. So that's 1/2 V, right? 1/2 V. Now, of course, you can do this, right? Now, you can also just draw something like this, right? Is V. Okay, something like really long, right? So 3 times long. Okay, let me just say this, right? So it's 3 times long, 3V. But the direction should be pointing to that direction, right? Same direction. And then you have 1/2, right? 1/2, half V. In other words, you do not have to put those position vectors in one coordinate, XY coordinate. You can just do this like this one, right? This one as well. Okay, either one works, right? Either one works. So 2, 5, 6 in total. That's 13 points. Okay. Some of us turned in the quiz, but I cannot read. All right, which is not readable. I believe you got to make sure that you have received the confirmation email, right? So just make sure that you submit your quiz successfully, right? Successfully. Otherwise, I just cannot read. It's all showing just in progress. All right, I cannot see anything from what you submitted.
That's what happened to me. I submitted it yesterday, and I woke up today, and it still says in progress. And I'm like,
oh yeah,
like
I know that's
I submitted it again. I don't know if that works. Would that be gradable? Like
uh
today at 9 in the
yeah,
morning.
I will check. I will check. All right, I will check. Okay. Mhm. So that's quiz 16. All right, it's going to be the final quiz we are going to have. All right. So now, also today is the last day of lectures. Okay, so we're going to have our final exam tomorrow. So for today, okay, the main part is going to be a reveal. All right, it's not going to be the lectures. Okay, but we will. Okay, there is a homework. All right, so we will do the homework and then finish the lectures and then do the reveal. And finally, we're going to talk about how to calculate our grade. Okay, so now let's consider homework 17. Any questions from this homework?
I have a question about the applications. Like at the end of it, it's like 69 to 77. Just do any of them.
Okay, yeah, sure.
Or 69 will be fine.
You know what? We haven't finished this section. Actually, the application is going to be similar to the questions we're going to go through today.
Okay, then it's fine. So
yeah,
without it.
yeah. Let's do that. All right, let's do that. We will go through the lecture first. And then another questions.
Can we do 29?
29. Okay. 29. That's 10.8. Uh, 29. Okay. 29. Oh, okay. This one, right? So I believe this one is similar to the quiz question we did, right? To the quiz question we did, right? It's finding the magnitude and direction of this vector, right? So for this one, we can solve it similarly. Okay, so you have 5, 6. So theta is in what? It is in the first quadrant, yes? It's in the first quadrant. Then what is the tangent of theta?
So will it be 10 negative 5 over 6?
Yeah, tangent 5 over 6. So this implies theta equals what? Tangent inverse 5 over 6. Yes, and this one is in this range, right? It's from 0 to pi because inverse tangent, you can find it, is in the first quadrant, right? It's in the first quadrant. It's between what? Between 0 and 1. No, between 0 and actually it's between 0 pi over 2. Okay, so that's good. All right, so this is going to be the direction and the magnitude. I believe you can do that, right? Square root of 6 squared plus 25, 5 squared. So
Yeah, I got the magnitude, but I was having the problem with the direction because I got lost with the quadrant. So
okay.
yeah, I got it now.
Okay, yeah. Good, very good. Okay, any other questions on the homework? Good. Okay, all right. Just feel free to let me know if you have any questions. Okay, so now let's go to our finish our lecture. There's just some very small part of the lecture. Okay, so let's do this one now. In last class, we talked about the vectors and give the definition and notation, and so how to find the position vector given the initial point and the terminal point, right? And then we talked about the vector addition, vector difference, and vector scalar multiplication. Yes, and then we just did this example. Now today we are going to move on, and we're going to talk about the following topic. The first we're going to talk about the unit vector in the direction of a given vector. Okay, so we call a vector with a magnitude of 1 a unit vector. This is the definition of called a unit vector. Okay, so for instance, you may have this 0, 1. What is the magnitude of this one? It's going to be what? Square root of 0 squared plus 1 squared equals 1. Yes. So its magnitude is 1, right? So therefore it is a unit vector. All right. Now you can also confirm for any theta. All right. This is cosine theta, and this is sine theta. Now this is also a unit vector because what? Cosine theta, sine theta. The magnitude equals what? Square root of cosine square theta plus sine square theta. As you can see, it equals what? Pythagorean identity, right? So answer is square root of 1. This one equals 1. Yes. So for any theta, this is going to be a unit vector, right? Unit vector. So now, what if we do not have a magnitude of 1, and we just have a single vector? But given the single vector, it has a magnitude, which may not be 1, but they have a direction. Yes, direction is a part of this vector, right? It is a directed line segment, right? So it has a magnitude and also it has a direction. So if this vector v is a non-zero vector, then we will have what? We will have this ratio v over the magnitude of v. It's going to be a unit vector in the direction of v, in the direction of v. Okay, so the proof is pretty simple. All right, so you can just v over, if you take the magnitude, it equals what? This is a constant, so you can take the constant to the front and times v, right? So, and this is a positive, so it is 1 over times the absolute value, the magnitude of v. So this one equals 1. Yeah, so you can see that this is always going to be, the magnitude is going to be always 1. Okay, so therefore, it is going to be a unit vector. Okay, so what we do is actually, given a vector, and the first step is to find the magnitude, right? To find its magnitude. And then just divide that vector by the magnitude. Then you got the unit vector. Yes? Okay, so very simple, right? The idea is pretty simple. Now let's consider this example. Salim, can you read for us, please?
Yes. Find the unit vector in the same direction as v equal -5, 12.
Very good. All right, so now for this one, this is a non-zero vector. So what we want to do is to find a unit vector in the same direction. Yes, so what we can do is what? Is just find the magnitude and divide this vector by the magnitude. Okay, so the magnitude of v is equals right equals 25 plus 144 which equals 13. All right, you can find this one equals 13 using the calculator. All right, so that's the magnitude of V, right? So has a unit vector in the same, the unit vector is what? It's V over the magnitude of V equals, all right, so it equals what? This 1 over the magnitude. Now you can just say this, all right, so it is actually what? You can just say the V is what? -5, here is 12 over 13, okay? So, but this division is going to be a simple, a scalar multiple, right? It equals what? 1 over 13 times, right? -5 and 12. All right, so which equals -5 over 13 and 12 over 13. So that is the answer. That is the answer, right? Okay, so we got the unit vector in the same direction as V. So now let me just ask you another question. What if we want to find a unit vector in the opposite direction?
Would you inverse the sign?
Inverse the signs. Very good. Okay, so it's going to be basically what? You got to find the magnitude, but you are going to take the negative, right? Take the negative using negative V, right? Using, oh, okay, just not here, okay? Right, so this is, okay, note. To find a unit vector in the opposite direction, we do what? That's going to be what? We do negative V over the magnitude of V. Okay, just take the negative, all right? Inverse the signs, right? And then you can get this one, right? So that's going to be in the opposite there. Because of what? V and the negative V, they are in the opposite direction. Okay. All right. So that, go ahead, Mustafa, do you have questions?
Oh, no, I was just on. Forgot
Okay.
to be on mute.
All right, good. Consider next is the dot product. All right, the dot product of two vectors, u and v, is the sum of the product of the horizontal components and the product of the vertical components. In other words, u dot v is AC, the product of the horizontal or the first coordinate, right? AC plus BD, all right, the product of the vertical component or the second coordinate. So it is AC times BD. All right, it's AC times BD. Okay. Now here is a very interesting, very interesting formula. Okay, very interesting formula is the cosine, the angle, right? The angle between two vectors is theta. Then we have the cosine theta equals u dot v, the dot product of u and v over what? The magnitude, the product of their magnitudes. All right, so on the top, that's the dot product. Over the bottom, that's the product of their magnitudes. And that's cosine theta. Make sense? Okay, very, very good. All right, now let's consider example here. Okay, Now, say Mustafa, can you read for us, please?
Giving u equals 5 at 5, 12, and v is negative 3, 4. Find u dot v, u times v, and find the angle between u and v.
Very good. All right, so here, solution A, we want to find the dot product of u and v. So u dot v equals what? The AC times VD, the product of their horizontal component, right? That is 5 times negative 3, plus the product of their vertical components. So that's 12 times 4, which equals negative 15 plus 48 equals 33. All right, so we have u dot v is 33. Okay, so that's part A. B, find the angle between u and v, right? Find the angle between u and v. So what is the angle? Let theta be the angle. Between and v, right? So we have what? Cosine theta by the formula, it equals what? U dot v, the magnitude of u, the magnitude of v. Yes. So then this one equals on the top. From A, we know that the top is 33, right? On the bottom, the magnitude of u is the square root of 5 squared plus 12 squared times the magnitude of v is square root of negative 3 squared plus 4 squared, which again equals, all right, 33 over square root of, now this one, you can find this one, actually, square root of this one, you can just find this one equals what? 13. Okay. This one is simply 13. Right? Square root of 5 squared plus 12 squared is simply 13. Right? And this one is simply 5. Okay, so you got this one. Now you find that this one equals 33 over 85. No, 65. Right? So that is the cosine of the angle between these two vectors. Now, then what do we have? Theta
The
is going,
inverse.
yeah, the inverse cosine, right? So cosine inverse 33 over 65. And you can use a calculator to find this line. What is this value?
$1.0383.
Okay, very good. All right, that is 1.0383. Okay. All right, that is the answer, right? So this is, of course, in radians. Okay. All right, so pretty easy, right? If you know the formula, I think everything is pretty easy for this one. Okay, find the dot product, find their magnitudes, cosine of theta, you given this one, and then you can find it. Okay. Now consider, oh, this is 37. Okay. Well, this is a similar question. All right, Joshua, can you read for us, please?
Given u equals 5, 2, and v equals 3, 7, find u times v, and find the angle between u and v.
Okay, very good. All right, so well, you better write this one u dot v or the dot product of u and v. Okay, u times v, well, it's in vectors, right? People rarely say the product of two vectors. Okay, it's a dot product, right? Because there are several different versions of product between vectors. Okay, so the dot product of u and v or u dot v, or u dot v will be also good. Okay. Solution. Okay, so now A, well, can you please go ahead and solve this one because we did a similar example before. Okay, can you do that? Okay, anybody got the cosine? What is this?
I got
Ah.
point. Oh, go ahead.
You can go. It's okay.
I got square root 29 times square root 58. 29 over square root of 29 times square root of 28.
Oh, sorry, this should be plus, right? Here should be plus. Sorry.
Oh,
This is 3 squared plus 7 squared. Sorry about that. Okay, so 29 over square root of what?
58. Oh, sorry, square root 29 times square root of 58.
29 times square root of 58. Which final answer is?
The final for theta, I got 0.7854.
Is that right? 0.78. No, I mean cosine theta. What is cosine theta?
Inverse. Cosine theta is 29 over 41.0122.
What is the your decimal points? What is this? What is this one equals to? Or you do not have to, right? You do not have to do that, but you can just do this, right? So
I got 0.7071.
7.1. Okay, let's say that, all right, because this is not very simple, right? So let's just find this one, and the inverse cosine 0.7071 is the final answer is what? What did you guys get?
0.7854.
4, yes. Okay, very good. All right, good. Okay, so all right, so that's the angle between the two vectors. Okay, so very good. Very simple, right? So you find the dot product and then find the cosine using the formula, take the inverse cosine. You got the theta. Now let's consider this example. Okay, so Natalie, can you read first, please?
Yes. Two children are throwing a ball back and forth straight across the back seat of a car. The ball is being thrown 10 miles per hour relative to the car, and the car is traveling 25 miles per hour down the road. If one child doesn't catch the ball and it flies out of the window, in what direction does the ball fly, ignoring wind resistance?
Okay, very good. All right, thank you. All right, so in order to do this, we need to understand. Okay. These can be viewed as the summation of two vectors. Okay, summation of two vectors. Now, when you say that this is down the road, right? Let's say that this is going in this direction, right? This is what? 25 miles per hour, right? So 25 miles per hour. It's going to be 25. Along the road, correct? Along the road. Let's say that this is. But if you're, if the back seat is, this car vehicle is traveling along the road, then straight across the back seat of the car, right? The back seat of the car is going to be what? In a right angle, correct? Of this road. Yes. Okay. So there is a back and forth. So with what? 10 miles relative to the car, right? 10 miles per hour relative to the car. So it is going the vertical direction, either to the top or go bottom, right? Does that make sense? Okay, it can either going this way or going this way. Yes. Back and forth, correct? You're throwing the ball either this way or this way, right? So it's back and forth. Does that make sense? It's going either to the top or to vertical, to the top or vertical downwards, right? So the direction. Now this speed is 10 miles per hour, right? So let's firstly assume that it's going upwards. Let's assume that it's going upwards, all right? So we will have something like this one, all right? One child didn't catch the ball and flies out of the window and it's going upwards, right? Then what we want to do is, if one child catch up, flies out the window, in what direction does the ball fly, ignoring wind resistance, right? So now this one is going to be what? The combination of these two speed into this one ball, one object. Yes. One speed is going horizontal speed, right? is 25 miles per hour along the road. Another one is the vertical speed, that is 10 miles per hour upwards. So now this, when we are talking about it flies out of the window, then it's going to be a combination of these two speed. Yes, a combination of these two speed. That is the vector summation. All right, the vector summation. Okay, so take the summation of these two speed. Okay, now we can write this way as, all right, so from 0, this 25 is going to be a vector going to the vertical direction if the vector representing this one. All right, let me just draw the XY coordinate. All right, over a XY coordinate, put the ball in this one, right? These are the X, here is the Y. So what is going to be the direction of the horizontal speed? The horizontal speed is, okay, let the horizontal axis be along the road. Right? Along the road. That's going to be, the vertical axis is going to be right across the back seat, right? So then everything will be good, right? Then the horizontal speed can be represented as a vector. Let's say V1. All right, this one equals what? It is going from 20, 0, right? 25, 0. 25, 0. Yes. And the vertical speed is V2 equals what? 0, 10. Right? Okay. So therefore the what? The combination, right? Their speed, these two combinations is going to be the summation of these two, right? So the speed well, okay, the vertical and the speed of the ball is, okay, V equals V1 plus V2. Okay, equals what? 25, 0 plus 0, 10. That is 25, 10. 25, 10. Right, 25, 10. Okay, so now can you determine the direction of this one? Direction of this is this vector, right? So you have tangent cos tangent theta equals what? 10 over 25. is 2/5, right? So theta equals inverse tangent of theta, right? And without no of 2/5. So this one equals what?
Got 0.3805.
Oh yeah, very good. 0.8
3805.
38. Then 1, right? 4 decimal place. It's going to be 0.8381. Yes.
No, there's a 0 after the 5. Or
Okay.
I got 38 points. I got 0.3805.
Oh, 3805. Okay. I see. Sorry, my bad. 0.3805. Okay. So that is the angle, right? This angle is if what? If the ball is throwing upwards, right? Upwards, or to the left of the direction, right? To the left of the direction of the road of the car, right? Or it can other ways go to the right. Yes, go to the right side of the road in the same angle, same amount of angle, right? This one is going to be negative of this one, right? So it can be either positive. Okay, so what direction the ball fly? So either it is theta equals this one counterclockwise or clockwise, right? So to that direction. All right. Similarly, theta may be negative 0.3805, right? It can be positive or negative. Yes, if what? The ball goes downwards. Goes downwards, right? Across the back seat of the car in the other direction, right? In the other direction. Make sense? Okay. So because it's going to be either upwards or counterclockwise or clockwise, right? So does that make sense? I believe this is similar to the question one of the question we had in the exercise problem. Okay, so two children, right? So do you see this? Okay. Well, did you see this? This is actually exactly the same question. Yes. Right. I just used this question, right? So, so what is the Masafa? What is the answer for this question? Did you check the answer?
what? What is it?
What is the answer for this 73?
The same one. The same 1.30538.
It's
Oh,
the
the
same.
direction.
It's the same thing, right?
Yeah.
Okay, that's good then. All right, that's what we get, right? So, very good. Now let's consider a second application problem here. All right, so Dongxu, can you read for us, please?
Suppose a body has a force of 3 pounds acting on it to the left, 4 pounds acting on it upward, and 2 pounds acting on it 30 degrees from the horizontal. What single force is needed to produce a state of equilibrium on the body? Draw the vector.
Okay, very, very good. All right, very good. Solution. All right, let's put this one in our XY coordinate. All right, so to say that this is in the origin. All right, this body is on the origin, right? So a force of 3 pound acting to the left. To the left. What is left? Right, this side. Right? So this amount 3, correct? Direction. 4 pounds acting upwards. Somewhere here, upwards. And then acting at from 30 degrees from the horizontal. So 30 degree means what? Means counterclockwise from the y coordinate, all right, x coordinate. Let's say that this is, this doesn't look like 30 degree. Two pounds, right? 2 pounds. So the length, the magnitude should be just 2. Right? Is that right? Okay, something like this. Now we want a single force is need to produce a state of equilibrium. Now basically it's going to be we need to find the composite force of these 3 single forces, right? And then take the negative of that force, right? So the total force should be what? 0, right? The direction should be because you want to get an equilibrium. So, you know, if you have another one, you need what? You need an opposite of the first we find the composite force of these 3 forces. Yes. So that is what? V1 plus V2 plus V3. Okay, V1 plus V2 plus V3. Now you need to know, denote all these 3 forces as vectors first. Yes, as vectors. Okay, so they have a direction and they have a magnitude. Yes. Okay. So for instance, to the left, the 3 pound acting to the left. All right. The force to the left can be represented as a vector say V1, right? Equals what? This is going to be negative 3, 0, because pointing to the it's pointing to the left, right? So it's somewhere here, correct? So from 0 to that, that's going to be negative 3, 0. Yes. The force to upwards, the upward force can be represented as V2, right? So V2 equals what? V2 equals 4 pounds upwards. That's what is that? What is the coordinate for that?
0, 4.
0 and 4, yes. 0, 4, right? So, and the 30 degree angle is the 30 degree, the third force, right? The third force can be represented as, okay, V3. So what is the coordinate of this one? V3. So the 2 pound is the magnitude. That means the length is 2. Yes? This length is 2. And this degree is 30 degrees. Now then, can you find the x coordinate and the y coordinate of the terminal point of this triangle? So that's going to be what?
Would that be 2 times the point of pi over 6? Like
yeah, 2 times
or 2 over 2
cosine
and 1
pi over 6, right? And 2 sine of pi over 6. Yes? So the x coordinate is 2 times cosine, right? And y coordinate is going to be 2 times the sine pi over 6. Okay, so because 30 degrees is pi over 6. So that is what? So what is cosine pi over 6? Anybody remember?
Square root of 3 over 2.
Yeah, so 2 times square root of 3 over 2, that become what?
Square root of 3.
Yep. And the sine pi over 6 is 1/2, right? 2 times 1/2, that's 1. So V3 is this one. Okay, so we got these V1, V2, V3, right? So V1, V2, V3. Now, the single force is needed to produce a state of equilibrium. In order for a body to be at a state of equilibrium, so the composite force should be what? No force, right? No force acting on it. So the magnitude must be 0, yes? The magnitude must be 0. So let the single force be V. Then V plus V1 plus V2 plus V3, the composite, right? The composite force, all right? So equals what? Should be 0, 0. That's become an equilibrium, correct? Yes. So what is V? It's gonna be 0, 0 minus V1 minus V2 minus V3. Yes. So it equals what? 0, 0 minus -3, 0 minus 0, 4 minus square root of 3, 1. Okay, so it equals -3 plus -3, -3, that is 3. So 0 minus -3 minus 0 minus square root of 3. That is x coordinate. Okay, for y coordinate is 0 minus 0 minus 4 minus 1. Yes. Okay, so we can do that. This one equals what? This one equals 0 minus -3, that's the square root of 3, right? Minus negative, that's 0.3, right? 3 minus, that's 1, 3 minus square root of 3. And -5. That is the answer, right? That is the answer for this one. Good. Okay. All right. Now let's move on. Okay. There is a similar question, I believe, in this one, right? So okay. As you can see, it is similar to these questions. 70. Okay, 79. Okay, as you can see, right? 79. Actually, I think it is just the question 79. Yes. It's just the question 79. Yes. Okay. So it's a similar question we did. All right. It's the same question actually. Good. Okay, we did the same question. All right. So that's what we have here. Okay. I believe that's all, right? That's all we have. Okay. Okay, that's all about the lectures. We're done with all the lectures for this semester. Okay, so now let's we want to let's firstly talk about this one. Okay, this is a grade calculation sheet. All right, I'm going to show you how we can calculate our grade for now. Okay, so I sent an announcement today actually about the grade calculation sheet. Did you guys receive it? It should be in your email. Should be in your email. Okay. Okay, here we go. Right, the announcement. Grade calculation sheet. Attached below is a grade calculation sheet we will use to calculate the final grade. You can simply download this Excel sheet. Right, you can simply download this Excel sheet and open it. All right, you will get something like this. Okay. Now, what you want to do is you simply put your grade, you know, your grade, right? Quiz 1, quiz 2, quiz 3, quiz 4, quiz 5, and then so on, right? You just input those values there. Does that make sense? Okay. And then exam 1, just input the exam 1 after correction. Okay, just input those after correction points. All right, so that raw score plug in there. Okay, now I'm going to just, you can just plug in your score there. Okay, and then everything will be calculated automatically. Let me just show you what I mean. All right, so I believe I can input something. Okay, so my Surface Pro is not very convenient in putting these ones. All right, this is 35, and say this is 14. 14, I got 12, and so on. Right, so you can just input yours. Okay, well, here I'm just giving an example. All right, let's say that I got these values. Okay, so all right, so let me just. Okay, well, how can I? Okay, you can. Okay, now this one is for me. It's just very hard to. Okay. Well, you can just do this. All right. So let me just say 14, 10, another 10. Okay. Now let me see if I can copy and paste. Okay, I'm going to just copy and paste, or you can just do yours. This is a hypothetical scores. All right, now you can see that if I copy paste, I got input all these scores, and in downwards here, I got this total, all right, 29 or 188. 188 is a summation of all these, what do you get, right? That's 188 is what I get, okay? So it's going to be quiz 1 through quiz 16. All the total scores from the quiz, from the 16 quizzes. Total possible score is this summation, as you can see, right? As you can see from the side is columns. Okay, come on. I hate change something. Okay, good. All right, so 229. And then you will get what? You will get quiz grade is the percentage you get from all the quizzes. Now for this one, you got 82.10. Did you see that? Okay. Now then after you got done that, and you can also see that the quiz is already automatically updated here. Okay, quiz, right? In yellow. And then you can just say here, right? Exam 1 after correction, say that I got 78. All right, I will just put 78 there. Okay. And in exam 2, I say I'm getting, say, 60. Okay, how about that? Let's say that, right? So this is what I get. Now you can see that right after this is in red, that's the percentage you get, which will be used to calculate your score. Okay, so and this exam grade in yellow here, in the yellow region here, are automatically updated. Below that, quiz 1 quiz, that's 30%. Exam 1, 20%. Exam 2, 20%. Final exam is to be determined, right? We don't know yet, right? 30%. Okay. But so your grade so far, right? So here is your grade so far. Okay, these are automatically calculated. All right. So your overall score is calculated like this. Your grade so far without the final exam. So the grade without the final exam, that's going to be what? 80% times 30%. Okay, so times 0.3, so that's 30%. And okay, so basically it is using 82.1 times 0.3, that's 30% for the quiz. 83.87 times 0.2, that's 20% for exam 1. 70.59 times 0.2, that is 20% from exam 2. That added up, you got the grade without the final exam. For me, I got what? For this one is 55.52066. And the total grade without final is 30%. So all the others is 70%. Yes. Now the current percentage so far is 55 over 70, right? Over 70, that's 79 something. Now, how many points do I need in the final exam to reach? All right, to reach 60 points, that's pass or not pass, right? If you pass, if you got over 60, you pass the this course, right? Then for this hypothetical student, you only need 14 or about 15 points from the final exam. I mean, 15%, 15% of the final exam, right? 15 points from the final exam. Now, in order to reach B, a grade letter B, you need at least what? 48 points, right? In order to reach C, you will need 82, about 82 points, right? In order to get a B, right? Now, finally, if you want to reach A, you need 115 points from the final exam, which is impossible, right? So that means what? It's impossible for these hypothesized students to get an A based on the current performance. Does that make sense?
How many points is the exam? Like if you get an 8 in it, full, the final one.
The final is it's around around what 90 or 100. It's close to 100, but may not be exactly 100.
Are you going to tell us like how many questions and?
Yes. I'm going to tell you how many questions. There are not many questions. All right. So the final exam, I have down 9, 10, about 10 questions. About 10. Okay. That's going to be the whole semester, right? So it's not too much. All right. It's going to be 140 minutes instead of just 1 hour, right? So it's going to be 100-minute exam. right? 1 hour and 40 minutes. It's a whole class period. Yes? So I believe you can just calculate your current score, and you will have an idea on your current situation and how many points you will need in the final exam, right? And I believe this will give you a clear picture of your current performance and what's your expectation, right? And from the final, right? So this will give you some idea on that. Does that make sense? Clear? Okay. All right. Now, all right. This is the grade calculation. I'm going to just stop this one here. Now I want to move on to what? To our review session. How about that? Good. Okay. All right. So here I'm going to give a final exam review for the whole semester. All right, for the whole semester. Okay. Okay. So this is the final review. Okay. So I'm going to upload. I believe I have already uploaded. Yes, did I upload this one or not? It should be somewhere. And don't worry, I will check. Okay, so I believe it is. Okay, I don't think I uploaded it somewhere. I will upload this this review. Okay, to say that announcement. All right, I will make a new announcement about this one and containing this review, final exam review. How about that? And the video will be also uploaded, right? So it should be good. All right, you have this one. Okay, so let's consider this one, section 1.1 from chapter 1. Okay, so in this section, we'll talk about the definitions of rays, what is the angle, and notations, right? So how to denote angle, right? And the measures of angles. You have degrees and radians. Convert the degrees to radians, convert radians to degrees, right? So you need to know how to do that. And angles in standard position, right? Standard position, what is the standard position for angle? Initial side is the positive x coordinate, right? Positive x axis. And then your terminal side is a rotated terminal side to where it is located, right? So that's the angles in standard position. And then we talk about arc length and sector area, right? You got to use radians, right? You got to find the radians of the angle, and then using the formula to find arc length and sector area. And another one is find the co-terminal angles. Yes, so do you remember that? Okay, that's about section 1.1. Section 1.2. Okay, the right triangles, opposite side, adjacent side, and hypotenuse, right? And based on all these sides, we need to be able to find the sine, cosine, tangent functions, right? So what are the definition? How to find them, right? So for instance, sine is what? Opposite over hypotenuse, right? Okay. Then unit circle, right? On a unit circle, you have the x coordinate of the point on the unit circle is cosine theta, right? The y coordinate is sine theta. Reciprocal functions, cosecant, secant, cotangent, right? So the cosecant is 1 over what? What is cosecant? It's 1 over what?
Sine.
Over sine. Secant is 1 over cosine, right? Cotangent is 1 over tangent. Reciprocal functions. Now, cofunction identities, right? So you firstly find the complementary score, pi over 2 minus theta, where in a right triangle, right? In a right triangle, the two acute angle, they are complementary to each other, right? So the sine of one equals the cosine pi over 2 of the other. Okay, well, that's the cofunction identities. Okay, and then using what? The trigonometric functions. how to use the trigonometric functions to find the height of a building, right? And the height of a tree, right? And so on. So we got that. That's section 1.2. Section 1.3, domain and range of sine, cosine, right? Pythagorean identity, finding reference angles. What is the reference angle, right? Reference angles. Using the reference angle to find the sine, cosine, and the coordinates. Okay. Co-function identities, and well, these ones. Okay, not this. Sorry, should have time. Okay, that's it. All right, section 1.3. 1.4. All right, tangent, secant, cosecant, and tangent, cotangent. The other trigonometric functions. There are even odd identities like cosine and secant. They are even, all the others are odd, right? So you need to know the even odd identities. Fundamental identities, right? Fundamental identities. And alternative forms of Pythagorean identity, co-function identities. Oh gosh, sorry. Forgot to remove these two. Okay. Well, anyway, this is, sorry about that. Okay, so that's it. That's going to be the section 1 through 4 in chapter 1. Okay, we did all these ones in chapter 1, actually, a lot of materials there. Now let's move on to chapter 2, section 2.1. Okay, we found the periodic functions, right? So what do we mean a period of a function? For sinusoidal functions, sine and cosine, right? So what is the period? Amplitude, phase shift, vertical shift, midline, right? So these are concepts. Section 2.2 is the other ones, right? So graphing a tangent function. What is the period? What is the stretching or compressing factor? Phase shift, vertical asymptotes, right? So all these characteristics about tangent functions. Now, cotangent functions, same, right? Secant functions, same. Cosecant functions, same. Yes. So you got all these ones for section 2.2. Now, section 2.3 is going to be the inverse trigonometric functions. You have the inverse sine, inverse cosine, inverse tangent. Yes. For all these ones, you have a specific domain and range, right? So you got to memorize those. Then evaluate the composite functions involving trig and inverse trig functions, right? So cosine inverse of, say, tangent theta, right? Something like this, right? Tangent of sine inverse, right? And so on. These are composite functions. Okay. Now, section 3.1, chapter 3, is going to be all the identities, right? Again, here, trigonometric identity, Pythagorean identity, even odd identity, quotient identity, reciprocal identities, and you got to use the identities to simplify a trig expression, right? Now verify a trigonometric equation and check those examples, right? So this section 3.1, 3.2, sum and difference formulas for cosine, sum and different formulas for sine, sum and different formulas for tangent, verifying identities, right? Based on these formulas and applications. Okay. 3.3, double angle formula. All right, for cosine, sine, tangent. What is sine 2 theta? What is cosine 2 theta? What is tangent 2 theta? Right? So half angle formulas. Cosine theta over alpha over 2, sine alpha over 2, tangent alpha over 2, right? So, and reduction formulas, right? Cosine square equals what? Sine square equals what? Tangent square equals what? Right? So these are the reduction formulas. 3.4, product to sum formulas. Product. There are 4 formulas, right? 4 of them. Okay. 1, 2, 3, and 4, right? Maybe it's a sine alpha sine beta, two sines, right? Sine alpha, cosine beta, right? Cosine alpha, sine beta, right? Cosine alpha, cosine beta. Product. These are the four different products. And then how to put these four different products into sums, right? Into sums. And there are formulas for this. It's product to sum formulas. And similarly, we have the sum to product formulas, right? You have the summation of two sines, summation of the sine and cosine, and summation of two cosines, right? So you can got that. Then section 3.5, trigonometric equation with a single trigonometric function, all right? So trigonometric equation in quadratic form, you are going to use the quadratic formula. Remember that? Okay, section 3.5. All right, chapter 4. Okay, chapter 4 is more recent, right? So it's a law of sines, section 1, law of sines. Okay, so what is law of sines? The angle side angle triangles. Given two angles and one side, can you solve this triangle? By solving this triangle means what? You find all the angles and all the sides, right? So ASA triangles and SSA, two sides and one angle, right? So four different cases. Remember, no triangle, right triangle, two triangles, and one triangle, right? So there are four different cases. Finding the area of an oblique triangle area, right? So there is using the sign 1/2 AB times sine of gamma, right? So the product of two sides times the sine of the angle between them, right? So times 1/2, of course. Now, section 0.72 is the law of cosines, right? You need to know how to use the law of cosine to find the opposite side. Yes, and also what? Find the cosine if the three sides are given, right? If the three sides are given, you can find the cosine as well. And then Heron's formula, right? If all the sides are given, how to use the Heron's formula to find the area of a triangle. Okay. Section 4.3. Polar coordinates. What do we mean by polar coordinates, right? So there is radius, there is angle, right? So r cosine theta plus I sine theta in the parentheses. Conversion between polar and rectangular coordinates, right? So given a rectangular coordinates, how to find its polar coordinates. Given a polar coordinate, how to find its rectangular coordinates. The next section is section 4.4 is the complex numbers, right? So definition, the real part, imaginary part, absolute value, polar form of complex numbers. You need to find the modulus, argument, product, sorry, not production. Product of complex numbers, right? So in polar forms, quotient, right? De Moivre's theorem, right? So to find the power of a complex number, right? So this is one. De Moivre's theorem 2 is find the root, nth root of a complex number. Okay. And then we have the final section is the vectors, right? So initial point, terminal point, position vector, magnitude, direction, vector addition, difference, and scalar multiplication, the dot product, and the applications. Wow, that's what we have covered over this whole semester. Yay! All right, so that's a lot of materials. Okay, so
I have
all
a
right.
question about
Okay, go ahead.
the homework that we did before yesterday. We didn't go over that.
Okay, sure. You mean the homework we did in
I think it's 16. Homework 16.
homework? let's see, what is the homework in which section?
It is 10.5.
10.5. Question 10.5, right? Okay, so
I have a question about like how do we answer like the form that we have to write our answer in the exam, the final exam.
mhm.
Do we leave it like the r cosine of the angle and then I sine the angle, or do we have to solve it all the way down to like the complex number?
Okay. So what your question it might be, all right? Is your question how to express a complex
answer?
number, the answer in polar form, right?
No, I just want to know how do you want the answers for the exam?
It's gonna be
Like
similar
for example,
to
43.
yeah. I understand that, but let me open this one, right? So for instance, we have similar examples in vector, right?
Yeah.
Let me show you here. These are just the absolute values. These are polar form, right? Polar form. Now, as we said, right? For instance, using the polar coordinate, I do want you to write it down as this in the bracket, in the box. Did you see this? This is in the polar coordinate, right? 2 times this, right? So you want to write it in this way. Okay, that's going to be R is this one. Does that make sense? You cannot just, you need to find the direction, the argument, and also the modulus, and put them in this form.
So we stop over here. We don't keep going to the cosine of pi 11 pi over 6 and the sine of 11 pi over 6.
You do not need it, because this is the, if you continue to that, that is going to be what? That is going to be the
Rectangular.
rectangular form, or the yes, the Cartesian or the rectangular form. Yes.
Okay.
If you do that, like what we did for this one, right? And we did this one. So polar form to rectangular form. So then you multiply them out, right? So that is the rectangular form. Very good. Okay. Any other questions, please? Zhongxu. Good. Salim.
I'm good.
Good. Jared. No questions. Natalie.
good.
Okay. All right then. Okay. All right. Let me see. Okay. Okay. Well, anyway, it has been a very, very happy journey, I would say, right? I enjoy our class quite a lot. All right. So it has been a great experience knowing you guys, and also studying, you know, through this short but fun semester. Okay. So
Absolutely.
I really hope that you guys do well on the final exam, and enjoy the rest of the summer, right? So even though
Right.
it's coming, right? The new semester is coming.
2 weeks.
Yeah, in about 2 weeks. Well, just stop by my office when we are back to the campus, right? So yeah,
Okay.
just feel free to drop by and say hello, and if you're around there, right? So my office is in CHHS, right? So College High School. You may need other math courses. So if you want to stop by, feel free to come. Okay.
All right.
Right. If you do not have any other questions, we can stop a little earlier today, and we'll see you tomorrow.